You have fallen into Event Horizon with John Michael Godier. In today's episode, John is joined by Dr. Ravi Kopparapu. Dr. Ravi Kopparapu is a planetary scientist at NASA's Goddard Space Flight Center. His research interests are in extrasolar planet habitability, atmosphere modeling and characterization, as well as identifying technosignatures and biosignatures. He is the co-chair of the American Institute of Aeronautics and Astronautics UAP study. Remember to subscribe to Event Horizon so you never miss an episode.
Dr. Ravi Kopparapu, welcome back to the program.
Thank you, John. I'm happy to be here.
Doctor, there have been some interesting developments in thinking recently on the idea of close technosignatures. We look at the stars, the distant stars for radio signals, but it's become more of a thing to look a little bit closer these days and see if there might be something someone left in the solar system at some point or passed through at the distant past, or there could be a defunct artifact out there or an active one or something like that, because there really isn't too much of a difference between 10 light years away and right here for all we know. Of course, there could be huge differences, but it's all stuff we don't yet know. All we know is the great silence. So why not look a little closer? Thinking in technosignatures has also entered onto NASA's plate and others. And what's the state of it now? I mean, are we ready to start searching close by? And that can mean within 3 light years, perhaps. Or are we still coming up with ways to do that kind of searching?
I think we still have some time to explore the solar system technosignatures, although some studies and some work is already being done by some of our colleagues related to searching the data sets that we already have. For example, we could do a search now based on the LRO data, the lunar reconnaissance orbiting data, to see if there is any unusual anomalies that we could find on the lunar surface. And for that aspect, we have some of our colleagues using machine learning and AI to scan through the images and the data sets that the LRO mission collected and see if there is any temperature dependence or difference between different sites on the moon, or if there is any color differences or any kind of heat, anomalous heat coming up from the lunar surface, things like that. And so because we have a good technology right now, or an emerging technology of machine learning, I think that's one good advantage that we can use that to explore this kind of solar system technosignatures. That's close enough to the moon and all. The same data, the same methodology can be applied for Martian surface as well. We have enough data, I think, now to at least see the images and explore the Martian surface data set and see if there are any anomalies. The anomalies doesn't mean that there is actually something extraterrestrial out there. It just means it's an anomaly. That's it. And so it's just a flag. That's just to tell out methodologies to train them to see if we can find something different from the natural environment. And if we go further down into the solar system, we can measure albedo variations. We also have interstellar visitors, as we have seen in the past few years about Oumuamua, using our ground-based large space telescopes. And one of the ones that coming up is the LSST, or the Vera Rubin telescope, that we could use to find nearby objects that are coming into the solar system. These are some of these interstellar objects, and there are estimates now that there are several of these interstellar objects that may be entering into our solar system. It's just that we happen to find one. That means there must be more out there. And so this is a really good era. I think we are just beginning to see the search being expanded because of these new technologies and new telescope coming up. And it's one of the ways we could expand beyond the radio technosignatures or the radio SETI.
So we litter space with all sorts of things. We're the only species we know of to have ever crashed a flying saucer onto another planet, which was Mars, with the back shells of the rovers. And we, as a matter of course, make a lot of space trash. And some of that space trash, to date, I believe 5 spacecraft, including Voyager 1 and Voyager 2, have become interstellar objects, essentially, or are in the process of becoming interstellar objects. They will be them. Doesn't mean anyone will ever find those needles in a haystack, of course, but they are out there. and we're proof of concept that civilizations make trash and send it into space. Do you think that we have much of a way to detect a small defunct probe, like what we've sent out passing through this star system? Just a completely dead one. The radioactive generators have all decayed. Millions of years ago. There's just what's left of this spacecraft, but it's artificial. Do we have any hope of ever detecting that level of a needle in a haystack?
So it depends on what are the observable characteristics of the probe are. If it is not emitting any active radiation like radio waves or thermal heat, it is very unlikely and highly unlikely given a certain size of the probe. If it is of the size of a Voyager or a Pioneer probe, or even New Horizons, the one that was sent to Pluto, probe, then I think it would be really hard. And if it's somewhere outside near the solar system, then it would be really hard to find that kind of a probe. However, if you have a probe that has a light sail, defunct probe that has a light sail, perhaps due to the reflectivity of the light sail from our star, maybe because of the albedo, which is the reflective measure of reflectivity, perhaps that could turn out as an anomaly, and that could be a potential technosignature that we could categorize. If their probe is not doing anything, unless it is really close by, I don't think we would be able to identify any of these multiple probes.
Now, what of something, this is one of my favorite things to imagine because it just seems so permanent. What if looking at asteroids for depleted things, a composition that just looks like something mined it at some point in the history of the solar system, could have been long, long ago, that just depleted it of things like iridium and things like that, asteroids are sort of known for. Is there any way that we could build a systematic catalog of asteroid compositions as we explore that could then be searched for odd looking ratios of metals that should be there but no longer are?
That is a possibility, but that assumes that we can measure the composition of some of these major asteroids, the bigger ones, and see if we can identify the anomalies in that. Like, for example, the D2H ratios, the deuterium to hydrogen ratios. If they have anomalously low deuterium to hydrogen ratios, then maybe they have been depleted by some means that may have been possible through industrial process. Or it could be an anomaly that particular asteroid may be an anomaly of a different formation mechanism that we are not aware of. But I think we do mention this in many of our publications, that they're just like a biosignature. There is no single biosignature that we can point to and say, hey, that's it. That's the signature of life. Because nature is so clever. Nature has so much experience in making different kinds of things over billions of years that we may not be able to come up with a false positive, but nature can come up with it. And so we always want to look for multiple biosignatures or multiple signs of technosignatures. And so if we see, for example, in this asteroid case, if we do see an anomalous compositional difference in the asteroids, we will need to come up with many additional signs that could point to a hypothesis, to a technosignature kind of one, because we may not be able to think how an asteroid could form with a different composition naturally, but nature may have a way to do that. However, if we have multiple signs of evidence from different ways, different methodologies and different techniques, that will push our robustness of these conclusions that it could be coming from a technosignature, a technology that could have created it. And so just the composition anomalies on an asteroid, I wouldn't consider that as a firm, robust technosignature. I would look for something else. I can't think of right now what would that something else be that could point out to a technosignature. But I'm sure my colleagues would be able to think about this.
Well, I can think of one, anomalous heat, just like the moon. Now that brings us back to the moon and Mars, and this is related in the question of longevity, because I tend to like close technosignatures that last a very, very long time. and just sit there on the moon for billions of years, which greatly increases our chances of actually seeing it, as opposed to something transient, which does hold the possibility, of course. But if you've had something sitting there for billions of years, then there you go. And the thing is, we know that the moon preserves crazy. Eventually, everything gets gardened away by micrometeoroids, but you still have billions of years for your technosignature if someone had ever been there. And then the other is that Mars, what's that look like as far as weathering? How long could something preserve in the environment of Mars, as say it was buried? Is there really that much of a difference from the moon, or is it a much shorter time span to see your technosignature? Certainly, if it's on the surface, I would think it would be.
That's again an excellent question and an excellent discussion point, John. Of course, this is an ongoing research work that our colleagues Adam Frank and Manaswi, I don't know if you know them, they are planning to do as part of our technosignature work to see how long a probe, or for example, the Apollo missions, and or have left some of the equipment on the surface of the moon, right? And so they are trying to find out how long would it take for that equipment to erode just from natural processes of meteorite bombardment or erosion from space weathering radiation. And I'm going to just guess this guess value is probably not going to be very accurate. I think it's going to take a couple of hundreds of millions of years for these things to erode away or to completely be gone from the lunar surface. But I would caution to wait for the publication that my colleagues are going to publish at some point, and then that would be the most accurate value.
It just hit me. There is such a thing as a bad surface in the solar system to land your artifact on and expect it to survive very long. One of them, obviously, is Earth with its horrific weathering. It's also probably one of the worst candidates to look for something like this in the solar system would be Europa, because of its active ocean and new surface showing that everything churns away. So any of the technosignatures would be at the bottom of the ocean. That's sort of an irony, isn't it? The best candidate for life off the Earth, or one of the best candidates we have, also is one of the worst places to look in a different context.
It's the same problem Earth also has, right? So it has an active plate tectonic movement. It also has various geological morphologies that keep changing with time. So if we are, maybe that's one of the reasons why we are not able to find a different technosignature on Earth, because Earth is a very active, geologically active planet. Even we can't find many of the geological aspects that may have happened a few tens or hundred millions of years ago, because they keep recycling. The Earth keeps recycling every few tens of millions of years due to weathering process. And so you're right. If that happens on an active planet like Earth or a Jovian moon like Europa, it's really hard to find any of these things. But there is another kind of problem with these airless bodies, Mercury or Moon, which is this bombardment of high energy particles, cosmic radiation, meteorites that could potentially erode away some of these defunct technology if they ever exist. That actually puts an upper limit on how long ago a potential probe could have survived on such kind of a surface. At least we can put limits on this if we can actually calculate how long does it take for these objects to get eroded.
It's interesting from a science fiction standpoint, because I wonder if Arthur C. Clarke and Stanley Kubrick thought about that when they made sure to bury the monolith on the moon that humans discovered. Notice it was down in a hole. They might have thought about that this needs a little bit more if it's going to last for a long time. It needs a little bit more shielding than just sitting on the surface.
That's right. And so that could provide a little bit of shielding, and it's a cold place, a nice place. Hopefully, when we have some sort of a lunar activity at some point in the future, we might be able to explore and see one actual exploration on the surface of the moon to see, if it is anything is out there, anomalous things.
That would be amazing. That would actually be better than a radio signature, is if we've just found some artifact somewhere. And just right. This was not made here. And that could happen, eminently so. It's just as easy, just as easily could happen this way as it could radio SETI, or some piece of trash or active probe cooking through the solar system, because we just haven't had the resolution to look until now. we wouldn't have even been able to see something like Oumuamua until we had pan-stars, and soon with LSST, Vera Rubin, we're going to see so much more of this anomalous stuff. Oumuamua is just the start, because just that we happen to see that right at the exact time when we had the capability means there's probably quite a lot of things like this out there that'll be passing through. Wouldn't you think that to be the case, that we should expect as soon as operations begin at Vera Rubin, which I think is next year, we're going to see a lot of these, and we're going to have a lot of mysteries coming up? Do you anticipate that?
I do actually, because imagine these, even if with our limited telescope time and the size of the telescopes, the capability of the telescopes compared to the Vera Rubin one, we are still able to find a couple of objects. That means the total number of objects must be quite large out there, just because there are more number of them. So even with minimal capabilities and efforts, we are able to find them, means that there are quite a bit of them out there. And that actually is a really scientific bonanza, I would say, that we would be able to do. In fact, if you look at the history of astronomy, or in general, the science, but I'm going to focus more on astronomy because we're talking about telescopes here. Whenever we point a new instrument or a new telescope towards the skies, we have always found unexpected things. This happened with the radio telescopes. This happened with the gamma ray observatories, X-ray observatories. In fact, one of the things was the Jocelyn Bell's discovery of these pulsars, right? Back in the 60s. And when they thought they were coming for the signals, the radio pulses were coming very regularly. And there was at that time no known natural phenomena that was going to give regular pulses. And then they called it little green men. And then, of course, later on, we found out that it was rotating neutron stars or pulsars. And so I am very confident that as soon as we point out new telescope like Vera Rubin, I'm sure we will find things that we have not even imagined at the time.
I always like to think about that with the discovery of the pulsars, because again, they didn't immediately jump to it. They just, I think, almost jokingly called it LGMs, but they were like, maybe, could be. But at the same time, the reality of what was behind those signals, the idea of a rotating neutron star pulsing like this with such perfect regularity, to me is every bit as weird as finding aliens. This mysteriously weird object in the universe that we had no idea existed before, although I wonder if someone had actually predicted it before then. But anyway, I know black holes were. So it was just as weird as aliens. And I think we're used to neutron stars now that we hear about them all the time. But back then in the 60s, I'm not sure. That's strange, but they exist nevertheless.
Right. So what happened, in fact, another thing that were predicted were the Jupiter-sized planets very close to their stars. I mean, in our solar system, we have Jupiter at 12-year orbit around the sun, right? So everyone, when we were looking back in the 80s and 90s, early 90s, when we were trying to find planets around other stars, we were all looking for 12-year orbit Jupiters around sun-like stars. And we haven't found any at the time. And then some graduate student at Cambridge, Michelle Mayer's graduate student, Deirdre Kilo, he said, well, let's look at smaller orbital periods, smaller distances from the star. And then that's when they found the first exoplanet. And that happened to be a big Jupiter-sized planet around a sun-like star orbiting in about 4 days. And everybody thought, oh yeah, we never thought about that. Actually, we never thought we would be able to detect these kind of planets actually even exist. However, if you go back into the history of these exoplanets or the stars, back in the 1950s, I think Otto Struve, who was director of an observatory, I forgot which one, he actually predicted that you should get a big signal from these Jupiter-sized planets close to the stars. And everybody forgot and then rediscovered it when the observations happened in the 90s. And so I think we should learn from history that we should be able to expect the unexpected. Nature can definitely make things that you think will not happen.
And then they become the expected once because now we know to look for things like super Earths as a norm and hot Jupiters, as you mentioned, as a norm for star systems, yet this one does not have one. And more importantly, perhaps, this one also has a planet that has sported oxygen for several billion years that is put there by life, which is not a total it's not a total biosignature. There can be other things producing oxygen in a planet's atmosphere. However, and he sent me a link to a paper by Balby and Frank that was recently done that said you need that oxygen for everything a civilization does, including complex brains and smelting metal. You need that oxygen and combustion and all of those things, and that maybe you should look for these systems that have these oxygen worlds, and then that might be a reason to send a technosignature to them. What are your thoughts on that?
Right. So I think oxygen is obviously relevant for, not only relevant, it's one of the most significant molecule for complex life, even for technology as well, apparently from this paper from Adams and Amedios. This is, I really like this paper. And the reason why I really like this paper is because they've actually, until now, as an astrobiologist and trying to find biosignatures, I was always interested in biological activity and how oxygen is relevant for biology on Earth and on exoplanets. I never thought about how oxygen would be, relevant for technology. I had kind of an idea, but then this paper goes through really well how oxygen is actually needed to build a technological civilization. I don't know if you read the book *Sapiens* by Noah Harari. In the first few pages of the book, the author mentions that until the technological development on Earth, or even before the agricultural revolution, there is not much difference between us and any other animal on this planet, because we are just like another species, just going on about our business. And then the first technology happened. That's the first technology was the agriculture. And then actually, I would say even further back, the first technology was fire, and then came the agriculture, and then came the tools and things like that. So the first technology was fire, and then that happened because, according to this paper that Adam and colleagues wrote, is because the Earth had to reach a certain oxygen level for combustion to start. Combustion is where we actually use it for several things. If you have an oxygen atmosphere, we use it to cook food, which gives a much more high energy density. We use it to make tools, and then eventually, as a civilization develops, we use it for metallurgy, and from metallurgy we can begin making metal tools, and essentially where our civilization started to take off. And so this paper really opened my eyes in terms of how oxygen is so important for a technological civilization to develop. This also gives us a direction in what kind of exoplanets we could be looking for a technological civilization. So if you see a planet that has an oxygen atmosphere somewhat similar to Earth, then that is a very good candidate for both biosignatures and technosignatures. And if you see a planet that has how Earth was 2.7 billion years ago, where there was no oxygen, but only methane and carbon dioxide, but still life was there, microbial life, of course, single cellular life. And that might be a good candidate for a biosignature, but may not be necessarily for a technosignatures. And so I think this paper gives a really good direction of what kind of a planets we can categorize between technology and non-technology.
There is a peripheral here, though, that, believe it or not, relates to radio SETI, in that people that make an argument against radio SETI often will say, well, aliens won't use radio anymore. They'll be so advanced that they're using, I don't know, neutrinos or some faster than light technology. But the thing is that radio is a property of the universe inherent to it. It isn't an invention, it's a discovery. We discovered radio and then we harnessed it. We did that with fire. As you said, that was the first thing we did. Even precursors to Homo sapiens did this, and we inherited fire. There are now more fires artificially burning on Earth than there ever has in the history of tool use on Earth. Right now, there are more fires. Everybody has a little one that uses gas heating. There's a little fire in there all the time, a pilot light. And we never abandon fire. And I don't think we ever will, because that's ultimately how we make anything, or make a lot of things anyway. And as a result, it never goes obsolete. So do you think radio is in that same basket, and that it will never go obsolete. It will always be useful. It will always be the best way to do things like radaring asteroids, dangerous asteroids, and things like that. What are your views on that?
I think so. I changed my mind on this topic actually. I was under the same impression that people you said were thinking, okay, radio will become obsolete. And after discussing with some of my colleagues, I found out that we still have several technologies that we still use. For example, agriculture is a technology. We still use it to sustain our civilization. We use fire, as you said, one of the things that we are still using, and I'm sure we'll still be using it. But radio is for communication, right? So what I think we have to categorize it in terms of what kind of a technology is are we still using. If it is for our sustenance, like fire or agriculture, then I think it is a long-lived technology that any civilization will definitely need. So those are the kind of technosignatures we could still be looking for. An agricultural civilization or a civilization that still is using fire. However, if we are looking for a technological civilization that is trying to communicate within themselves or within their own solar system or planetary system or trying to communicate externally to other planetary systems, then we should think about what are the older communications technologies that we are still using before radio was developed. And while we're talking here, I can what was the long distance communication we used before radio? I think it was just a mode of transportation physically going there, right? Using ships, trains, or mobile vehicles. And even before that, it was just people going from one place to another place. So it's actual physical mode of communication that we used. Are we still using that kind of a technology now for communication purposes? Maybe in some cases, yes. Maybe in most majority of the cases, probably not. And so this kind of argument kind of made me think that, okay, maybe radio will never go extinct, but it will still be there lingering out, even if we develop a communication technology like a quantum communication or something like that.
That's why I like radar, because it's so powerful and it's so useful. And you're not going to do that with a neutrino, non-interactive particles. It's a lot harder to capture that and communicate with it or bounce it off something than it is a light, a photon. So I just can't see it ever going obsolete. Now, with this idea, though, with the oxygen idea and the combustion, there's another side to this, because it could well be that ocean worlds that have an appreciable amount of land in which to have a fire are common. And that's the usual, is an ocean world is the norm. And there are some models that suggest that. But you can't smelt and you can't light a match underwater. As smart as the octopus could be, it can't light a match, and probably never will as long as it's in that environment. So do you see the presence of large-scale oceans, even with oxygen, photosynthesizing oxygen from an analog of cyanobacteria or something in an ocean, even with oxygen, but too much water is also a showstopper for technological civilizations? They can be as smart as they want, but they're stuck in an ocean.
So I may want to split this into two different things. One, an ocean world with oxygen, and an ocean world and ocean world with oxygen and some land on it. And I don't know how an ocean world with just oxygen will survive for a long time, because at some point, I don't know what will happen to that oxygen, given the large amounts of ocean on the planet. If there is only just water on the planet and no land and some oxygen in the atmosphere, I can't see how a technological civilization could develop on the planet, because it has to all be subsurface or sub-ocean. Even if there are hydrothermal vents, even if there are minerals available under the oceans, maybe there would be some primitive form of life, maybe some advanced form of life, because the oxygen is available and maybe gets dissolved in the water and probably promote some sort of a complex life form. I'll have to consult my biology colleagues that can even complex life develop under ocean worlds, even if it has oxygen in the atmosphere. Because how does that oxygen go into the deep oceans and then help the single cellular organisms develop into multicellular organisms? So forget technology, can we even have a complex life form if you have just an ocean world and an oxygen atmosphere? However, if you have an ocean world with some land on it and oxygen atmosphere, I think that is a good possibility, a better possibility for having a complex life and has a potential for technology because then the organisms can come on the land, try to breathe the oxygen, try to see how they can develop into complex life forms. And, if everything works out, they can become a technological civilization like ours. In fact, this is all based on one example, the Earth as an example, right? So we didn't have any complex life form 2.7 billion years ago before oxygen came out. It was all very rudimentary microorganisms. And so I would probably vote for a planet that has at least some land surface on the surface with oceans and oxygen to have a technologically capable or even complex life capable state for that planet.
There actually was a recent finding reported. I don't know if you saw it, but it's rather creepy, and it's called dark oxygen. And they started, and these researchers were actually industrial researchers. They were looking at manganese nodules that form on the ocean floor as a potential source for mining. And the deeper they went, the higher the oxygen started going up. It started going up when they were going deeper, where they were expecting it to be depleted. And it's a chemical process that's producing this oxygen, releasing it. Totally abiotic. It's just these nodules, the ocean just forming these things up, chemistry. But yet there was oxygen down there. And how far back does that go? Was this present early on? Could this have influenced? Doesn't look like it because of the anaerobes, as you mentioned, but there may be ways for oxygen to show up in an ocean, at least in small amounts, that we didn't even know was the case before a year ago. So again, what's that change? And that is the beautiful development of science as an ongoing revisionary process, I suppose.
Right. So, as you're mentioning this, we have to think about what was the oldest complex organism that was on Earth, that actually developed on Earth. If I remember correctly, that happened about 600 or 550 million years ago by, a large animal, not, I wouldn't say animal, a large organism that probably lived on the seafloor. And it's not a coincidence, right? Around that time, oxygen level was not as much as today, but definitely more than 2.7 billion years ago. So then the question is, why wasn't there a complex organism 2.7 billion years ago when there was CO2 and methane? Because lack of oxygen. Again, it comes back to the oxygen, as you mentioned. And so to even if there was a little bit of land surface or even if there was ocean surface, we definitely need oxygen to develop complex life. And from complex life, we will develop to, even advanced life and advanced life to, technology and so on.
Now, can we envision a situation where you can have too much oxygen and you end up with a fire world that resets due to massive wildfires, resets itself and never gets towards technology just because there's too much fire, too much oxygen production? Can too much be just like the oceans with too much water? Can there also be just simply too much oxygen?
Yes. So we actually worked on a paper recently where we tried to see how oxygen levels varied over the last 580 million years ago. I think around 300 to 250 million years ago, between 350 to 250 million years ago, there was a peak in oxygen level, and that went up to around 30 to 35%. And the current level, as you all know, it's at 21%, right? And of course, you can imagine what would happen at that high level of oxygen. Everything catches fire at those high levels. And then in fact, we know that that's the level of oxygen, 30 to 35%, because of the charcoal record at that time, because things started burning because there was too much oxygen. And so I think there is a self-limiting oxygen level, I believe, where, eventually the planet will get reduced oxygen level to where it becomes a sustainable one.
All of this starts looking like a pretty viable solution to the Fermi paradox, is that civilizations are rare because it's hard to get there. You need water for life to arise. You need fire. You need oxygen. You need land. It keeps going. And just to get to the conditions that you need to create advanced technology, doesn't seem like that's going to be very common, does it? Especially with the exoplanets we've seen so far. Granted, we have a very limited view on that, but it starts to look like this might be rare. And if it is a rare situation, it almost seems like it would be a collection point for technosignatures, because everybody's going to want to take a look and see what's going on here. And that it should be made perhaps natural to look at close SETI, because this might just be the exact type of star system you'd want to send a probe to. What are your thoughts?
Well, so I'm not entirely sure if it is rare or not, because if I'm going through the most common elements in the universe, hydrogen, the next common element is the helium, which is inert. It doesn't react with anything, helium. And the third most common element in the universe is oxygen. And so if we just see the top three, two of the most common elements in the universe are hydrogen and oxygen. So, and guess water is made of? It's H2O, hydrogen and oxygen, right? So I think water in some form may be abundant in the universe, and oxygen is also abundant according to the natural element formation. And then after oxygen comes carbon, and then nitrogen, and so on. And so if these things seem to be common in the universe, so while our current exoplanet population may be telling us something about the formation mechanisms and also about the atmospheres of these planets, I think this is mainly based on our observational bias, because those are the ones that we are able to detect. It's like looking for keys under a street lamp because that's where the light is, but that's not where you lost your keys. And so we know that there are way more terrestrial planets, Earth-sized planets. I'm not saying Earth-like, it's Earth-sized planets than super Earths or Jupiters and so on. There are way more pebbles than boulders. And so if that is the case, then it is expected that many of these planets may have hydrogen or oxygen, or combination of these compounds. And so I expect that many of these planets may have water on them, which is just that we don't have yet the capability to detect them. We just need to build the instruments to find them.
It is rather amazing that oxygen really is very common, and so is water, because you just see it everywhere. I mean, you can get a telescope, an amateur telescope, and look at a nebula and see the blue glow of oxygen, a lot of it, and it's just out there. The question is the relation to life creating it on a planet. That's interesting stuff, because we start seeing oxygen signatures in exoplanet atmospheres whenever we get that capability. There's going to be a lot of debate about that. I guarantee it. No matter what it is, no matter what's responsible, there's going to be a huge amount of debate in the scientific community. And wouldn't you anticipate that as well?
Yes, definitely. Look at what happened to the phosphine on Venus topic, right? We don't even know if the phosphine detection is real, or even if it is real, we don't even know if it is there or not, or in enough quantities. However, a significant amount of resources in terms of telescope time, human power, have been dedicated to look for further observations to find if there is phosphine on Venus. Just to give a background, phosphine is something that could be produced by biology on Earth. And so when there was an announcement back 4 years ago, they found phosphine on Venus and everybody got excited. Some people wanted to reconfirm it, and it's still debatable whether its actual detection was made or not. But just the fact that there was a hint of phosphine on Venus, potential hint of phosphine on Venus, made a lot of difference in terms of how scientists and the public also paid more attention to that kind of signal. And that generated a lot of back and forth. And that is happening only is for a planet that's next to us, Venus. Imagine if we find something like this on an exoplanet. I'm 100% sure there's going to be an extensive debate on the discovery, and then there will be more attention paid to it. And it is definitely needed for science. That is how science progresses. You criticize it, throw stones at it, and then whatever stands at the end is a robust result.
Absolutely. That's the first thing you start with. Try and knock it out. Do everything you can. And then when you can't, then you tell everybody, and then they try to knock it out. And then if nobody can, there you are.
That's real.
And I think that'll probably happen with anything regarding close technosignatures too, because, I never liked the idea of an extraordinary claim requires extraordinary proof. I think it's just a claim requires proof. And we ultimately, maybe we'll find it closer rather than further. And that we might have had a different kind of bias against close technosignatures in favor of distant radio signals. Do you think that's completely possible? What are your sense of the odds of finding it close or far?
Oh, that depends upon what kind of eyes we are using. Let me explain what it means. If we are using a technology or an instrument to look for a specific thing and not paying attention on something else, then we will not find it, right? So if we are spending more resources on radio SETI and more technology on detecting radio signatures, then because we have spent so much time and so many resources, I think there may be a higher probability of success over there. However, there could also be a chance where if we were trying to look for technosignatures that are not radio related, which are just taking images or taking spectral observations of things like that, unless things are so vast in number, if we won't be able to detect them if we don't pay much attention, just like what we were discussing with the Oumuamua, right? So we weren't expecting to find that kind of interstellar object. However, we found one with our limited telescopes and not even looking for something like that. That means there are so many of them that we just happen to find one, right? So this is the same thing I think will happen with either Radio SETI or the technosignatures close to our Earth. Unless there are so many technosignatures around the Earth, it might be hard to identify some of those nearby technosignatures compared to the radio technosignatures, only because we are spending more time of them. And another thing is that in radio technosignatures, we know what we are looking for, at least the narrowband radio signals. Whereas something close to the Earth, we just don't know. And it also assumes that we can recognize a technosignature when we see one. What if the technology is so far advanced that we can't even recognize it as a technology, but something anomalous, right? So, or something totally different from our natural observations, just like the one we talked on the moon, for example. So we have to be aware of what kind of things we might be able to find, what were our biases when we are looking in the data. That's when we will be able to find fundamental discoveries. So that is the way science does.
And I look forward to more of it. It's going to be an interesting 50 years, if I make it that long. Dr. Kopparapu, it's always a pleasure having you here, and we'll have to do this again sometime soon, next time another paper or interesting development happens in the search for close technosignatures.
Yes, sir. Thank you so much.
Event Horizon and my channel are now available as a podcast on Apple Podcasts, Spotify, and YouTube memberships. Early ad-free episodes, bonus episodes, and sleep-focused content. Sign up now by clicking the links below to your platform of choice.